For 60 years, we've called Mars our backup planet, the place we run to if Earth fails, the second home waiting for us out in the dark. There's just one problem. Mars doesn't want us there. In almost every way, a place can be deadly. The air, the cold, the radiation, even the dirt under your boots. Mars is actively trying to kill you. So the real question isn't, would we like to live on Mars? It's whether we can, and what it would actually take to survive a world built to end us. Let's get into it. First, why Mars at all? Of every world in the solar system, Mars is the least hostile that isn't Earth. And that's a low bar. A day on Mars is 24 hours and 39 minutes, almost exactly ours. It has seasons. It has polar ice caps. It once had rivers, lakes, maybe an ocean. Billions of years ago, Mars may have looked a lot like the early Earth. That's the dream. A planet we could, in theory, rebuild. But in theory, is doing a lot of heavy lifting, because the Mars of today is a frozen, irradiated desert with almost no air. To understand the challenge, you have to make the trip, and the trip alone is brutal. The company betting everything on this is SpaceX. Their plan rests on one machine, Starship, the largest rocket ever built, designed to carry around 100 people and tons of cargo to Mars, and then be refueled on Mars to fly home. The vision is staggering. Not a flag and footprints, but a self-sustaining city of 1 million people. Musk first laid this out in 2016, in a plan he later published in a scientific journal. And his argument isn't really about exploration. It's about insurance. A self-sustaining city, he says, is a backup drive for human consciousness, large enough to keep going even if the supply ships from Earth stop coming forever. To get there, he wants to launch whole fleets every 26 months, each time Earth and Mars swing close, and drag the price of a ticket down from billions to roughly the cost of a house, so that going to Mars becomes a choice almost anyone could make. Now, the timelines have slipped, again and again. Predicted, first crews have come and gone, but strip away the hype, and the core idea is sound. And it's why Mars, not the Moon, is the target. The Moon has no atmosphere to work with, days that last a month, and dust like powdered glass. Mars, for all its horrors, has the raw ingredients: carbon dioxide, frozen water, and a real day-night cycle. If we're going to live anywhere else, Mars is the best-worst option we have. So you board the ship. Here's what the journey actually costs you. Mars is, on average, around 225 million kilometers away. With today's rockets, the trip takes roughly 7 to 9 months. 7 to 9 months sealed in a metal can smaller than a studio apartment, with the same few people, watching Earth shrink to a pale blue dot behind you. And space is not empty. Out there, beyond Earth's protective magnetic field, you're soaking in radiation, galactic cosmic rays, and bursts from the sunday. Using a detector on NASA's Curiosity rover, scientists estimate a full Mars mission. The trip out, the stay, and the trip home would hit an astronaut with roughly 1 sievert of radiation. That's about a whole career's worth of safe exposure, absorbed in a single journey, and it measurably raises your lifetime cancer risk. Then there's your body. In zero gravity, muscles waste, bones thin, fluid shifts to your head, your eyesight can change. Astronauts exercise 2 hours a day just to slow the damage. And then comes the landing, what engineers grimly call the 7 minutes of terror. Mars is a trap here too. Its atmosphere is thick enough to set your ship on fire as you tear through it, but far too thin for parachutes alone to stop you. Every successful landing has needed a frantic, perfectly timed combination of heat shields, chutes, and rockets, all running automatically, because Mars is too far away for anyone on Earth to fly it for you. Roughly half of all missions ever sent to the surface of Mars have failed, and those were robots. There were no people on board to lose. So picture it. After that, the radiation, the wasting, the months of isolation, you finally touch down in one piece. And this is where it gets worse, because now you have to survive the planet itself. Step outside without a suit on Mars, and you have less than 2 minutes. Let's count the ways it kills you. The air. Mars has an atmosphere, but it's barely there, less than 1% the pressure of Earth's, and it's 95% carbon dioxide. There is essentially no oxygen to breathe, and that thin pressure is its own death sentence. It's below the limit where the water in your body would literally start to boil at your normal temperature. No suit means your saliva, your tears, the fluid in your lungs, boiling. Not fire boiling, vacuum boiling, just as lethal. The cold. The average temperature on Mars is about -60 degrees Celsius, -80 Fahrenheit. On a warm summer day at the equator, it might briefly climb above freezing. At the poles in winter, it drops to -125, cold enough to freeze carbon dioxide straight out of the air into dry ice snow. The radiation, again, Earth has a global magnetic field and a thick atmosphere that shield us. Mars lost its magnetic field billions of years ago, so radiation from space slams straight into the surface. Stand on Mars unshielded, and you'd absorb in days what we'd consider a safe limit for a whole year. Long-term, any colony has to live underground or under meters of soil. Your dream Martian city? It's mostly a basement. The soil itself is poison. Martian dirt is laced with perchlorates, toxic salts that damage the human thyroid. You can't just grow potatoes in it, like the movies. You'd have to wash and chemically treat the soil first, or it poisons your food and your lungs. The dust. That same dust is incredibly fine. It gets into seals, joints, filters, lungs. And every so often, Mars throws a planet-wide dust storm that can blanket the entire globe for weeks, blotting out the Sunday. If your power comes from solar panels, a single storm can starve your whole colony of electricity. One of those storms is what finally killed NASA's Opportunity rover. And finally, gravity. Mars has just 38% of Earth's. We genuinely don't know what that does to a human body over years, to a pregnancy, to a child who grows up there. We have 0 gravity data and 1 gravity data. Everything in between is a guess we'd be making with people's lives. So, no air, lethal pressure, killing cold, constant radiation, toxic soil, smothering dust, and gravity we don't understand. That's the planet. Now, how on Earth, or rather how on Mars, do we survive it? Here's the part that's genuinely hopeful, because for almost every one of those killers, we already have the beginnings of an answer. Start with air. We don't have to ship oxygen from Earth. We can make it there. In 2021, a toaster-sized device called MOXIE, riding on NASA's Perseverance rover, pulled carbon dioxide from the Martian atmosphere and turned it into pure oxygen. It worked. It was tiny, but it proved the principle. Scale that up, and a colony breathes off the air that's trying to suffocate it. Then water. Mars is hiding enormous amounts of it as ice, at the poles, and frozen just under the surface across much of the planet. Melt and purify that, and you have drinking water, water to grow food, and something even more valuable. Split that water into hydrogen and oxygen, combine the hydrogen with Mars CO2, and you can manufacture methane rocket fuel. On Mars. This is the key that makes the whole plan close. You don't have to carry a return trip's worth of fuel across the solar system. You make it when you get there. Scientists call this living off the land, in situ resource utilization. For shelter, the first crews live in their landers and inflatable modules, then bury them, or themselves, under Martian soil and ice for radiation shielding. Later, robots could 3D print thick walls from the regolith. Food comes from sealed hydroponic greenhouses, not open fields. Plants grown in water and light, safe from the poison soil and the cold. Power comes from a mix of solar and, more reliably, compact nuclear reactors that don't care if a dust storm blocks the Sunday. But here's the cruelest part of all, and it's not about hardware, it's about distance. When something goes wrong on Mars, you can't call Earth and get an answer. A radio signal takes between 4 and 24 minutes to cross the gap, each way. Ask a question, and the reply is half an hour away at best. There is no rescue ship standing by, no next flight for 2 years. If a seal fails, if the crops die, if someone gets sick, the colony solves it alone, or it doesn't get solved. To live on Mars is to be more isolated than any human has ever been. Every settlement has to be its own hospital, its own farm, its own factory, its own world. Put it together, and you get the realistic version of a Mars base. A buried, pressurized, nuclear-powered settlement that breathes its own air, drinks its own water, grows its own food, and fuels its own ships. Hard, almost unimaginably hard. But not magic. Every piece is something we can point to today. But forget, for a moment, what's merely likely. Let's dream, because that's the part the science can't give you, and it's the part that makes people willing to risk everything to go. Picture Mars 2 centuries from now. Not a base, a city, glass domes catching a pale pink sunrise, with forests sealed inside, the first trees ever to grow on another world, trains gliding through ancient lava tubes, natural tunnels that shield them from the radiation above, farms glowing soft purple under grow lights, and children who were born here, who have never felt Earth's gravity, who look up at a small blue star in the evening sky and call it the old planet. They'll have their own slang, their own art, their own holidays, a second branch of humanity, no longer betting its entire existence on a single, fragile world. It's a beautiful dream. And to find out how far away it really is, you have to ask the question every science fiction fan eventually asks: could we ever just make Mars into a second Earth? That, turning the whole planet into a second Earth, is what we call terraforming. The idea is to thicken the air, warm the surface, melt the ice, until one day you could step outside without a suit and just breathe. So, seriously, could we? The idea is to release Mars' frozen carbon dioxide to trigger a greenhouse effect, warm the planet, thicken the atmosphere, melt the ice. On paper, elegant. In reality, here's the gut punch. A NASA-funded study in 2018 looked hard at this and concluded that with today's technology, it isn't possible. There simply isn't enough accessible CO2 left on Mars to warm it meaningfully. Even if you released everything we know how to reach, you'd barely move the needle. And even in the most optimistic schemes, terraforming wouldn't take years or decades. It would take centuries to thousands of years. Terraforming Mars isn't a project for us. At best, it's a project for our distant descendants, and only if they invent tools we can't yet imagine. So, after all of that, can we colonize Mars? The honest answer depends entirely on what you mean by the word. A research base, a handful of people living on Mars, supported by supplies from Earth? The way we run Antarctica? That is genuinely within reach. Not easy, not cheap, not soon, but the physics works and the technology is mostly in view. Many experts think the first humans could set foot on Mars within the next decade or two. A true colony, a city that survives even if the ships from Earth stop coming, that grows its own food, makes its own air and fuel, and raises its own children. That is a vastly harder problem. It depends on technology we're still inventing and on biology we haven't tested. That's a multi-decade, maybe multi-generation project. And a terraformed Mars you walk on in shirt sleeves? With what we know today, not in any time frame that should shape your plans. That one stays in the realm of the far future. Here's the part most people miss. The biggest obstacle to Mars was never can we reach it. We've been landing robots there for 50 years. The obstacle is that Mars is a world engineered, by accident, to undo everything a human body needs. Surviving it doesn't take a rocket. It takes turning a death trap into a home. One buried, recycled, hard-won breath at a time. So Mars isn't our backup planet. Not yet. It's the hardest test our species has ever set for itself. And the strange, stubborn truth is that we might just pass it anyway. Not because Mars welcomes us, but because we refuse to take no for an answer. Thanks for watching. Stay curious.